Good evening. Hey, Toot My Itch. Hey, David, Reed. Welcome. Welcome to the first live stream lecture for Music 499C. So welcome 499C students. Welcome non-499C students. Yeah, so before we begin, how's my voice? How's the level? Can you hear me? It looks like you can. I'm also going to get ahead of myself a little bit here. Hey, all right. Okay, thank you. And I'm going to make a little sound just to make sure this is working as well. So you should hear pink noise. Do you hear pink noise? I'll try to make it louder, but if I turn my interface up too much, I sometimes clip the signal a little bit. I think the problem is that it's just hard for me to find a good place to put the microphone where it's literally right in front of my face. Wow, this is by far the most people I've ever had in my stream. All right, so let's get this out of here for a second. Okay, so I'm just gonna dive right in. I'm gonna cover the what we talked about in class on Thursday a second time, mostly just so it's on stream and recorded so that you can watch it again. And it's good to cover stuff a second time. And then we're gonna sort of just jump in. I'm gonna try to keep introductory concepts in an order that makes sense, but we might sort of jump around a little bit because topics are kind of interrelated and they depend on each other a little bit. So I'm sort of expecting, half encouraging you to have SuperCollider open at the same time while you're watching this stream if you're watching on a laptop, just so you can sort of follow along. So I'm assuming people have already downloaded it. You can get it at supercollider.github.io, I think. Is that the right website? I'm going to double check that. Yeah, supercollider.github.io. Whoa. Yeah, then you just click on download. Go ahead and download it and install it. Very simple. And I'm going to open it up. And just to recap what we covered in class on Thursday, what we're looking at here is the SuperCollider IDE, which is the environment that makes available a lot of convenient things that make programming sort of easy. We've got the workspace, the text editor, whatever you want to call it, on the left, and then we've got the help documentation on the upper right, and the post window, bottom right. And you can see, welcome to SuperCollider. Everything, no errors, no weird stuff. So you should see something sort of like this if you're opening up SuperCollider on your own computer. And SuperCollider is divided into 3 components, basically. Or it makes sense, anyway, to think of SuperCollider, what we're looking at here, as 3 different things. One is the IDE, which is this graphical stuff we're looking at here. And then there's sclang, also called the interpreter, which is the program that actually parses and evaluates your code and returns values and contains the class library and all the methods and all of the things that make this a true programming language. And we can see on the bottom here that the interpreter is active in green. They're right here. And then the third component is scsynth, also called the audio server or just the server. And that's the program that processes all the signal. So as you can see right now, the interpreter or sclang is active and the server is inactive. But we will get to booting the server a little bit later. And I'm just going to clear the post window here. And I think I showed this in class as well, but you can get to the preferences. I think on Windows it's like under the edit menu or somewhere else, but it exists on Windows as well. and obviously Linux too. And you can change behavior display, you can change the colors, and also you can look up any keyboard shortcuts for stuff, and you can also change these if you want as well. Okay. So to recap, evaluating code. We type code here, right? And every line with a semicolon, and Shift Enter will evaluate the current line. And everything that you've typed up until you've pressed the Enter key. So just, I'm going to hold Shift and press Enter. And the line is evaluated. And I can make a few more lines. I can say something like 5.cubed, Shift Enter, gives us 5 cubed, 8.sqrt, which is the square root method, and so forth. So Shift Enter is going to evaluate the current line. If I Shift Enter on a blank line, nothing happens. And right, and what I did in class last time, if we enclose code in curly braces, right, we can say, how would I explain what the semicolon means semantically? The semicolon is how you tell SuperCollider that's the end of this statement. Because SuperCollider doesn't really see spaces or return characters. So if I do something like var number equals 5, number equals number times 2. And I've just then enclosed this in parentheses, which means I can now click anywhere on or in this enclosure and press Command return, which evaluates the entire block. On Windows, that's Control return. And the semicolons here delineate discrete statements. Yeah, periods between sentences is also a good way to talk about it. So if I, for example, I'm going to clear the post window. I'm just going to delete the semicolon. If I try to do Command Enter again, we get an error message. And the error is syntax error, unexpected something. I was expecting something else. So sclang is like, look, I couldn't make sense of it. And that's because without the semicolon, we might as well have written this. Without the semicolon, there's just nothing. There's no space there. And so we have this completely nonsensical line, which doesn't make any sense. So if we run this again, we get the exact same message. And return is not sufficient. We can't just press return and expect SuperCollider to make sense of that. We actually have to put a semicolon. And as Unfearing said, semicolon it's like a period. Right, so if I press Shift return somewhere here, it's going to try to evaluate the current line, because that's what Shift return does. And we get an error message here, get an error message here. So if you want to run multiple codes as a clump all at once, you have a couple options. One is to enclose them in parentheses, which with each parens on its own line, and then somewhere with the cursor, somewhere in that collection, in that clump rather, Command Enter. You can also select multiple lines and press Shift or Command Enter, I think, in this case. Yeah, Shift or Command will work, and it the interpreter interprets whatever is currently selected. By the way, if you have any questions or need clarification on anything, it's kind of the whole point of having a live lecture instead of a pre-recorded one, is so we can talk to each other. Right, another thing I covered in class was these variables, right? So if we get rid of this line here and then try to run this again, we get error, variable number not defined. So any sort of word or, collection of letters that starts with a lowercase number needs to be declared as a variable, like this. And this tells SuperCollider, okay, so we're going to be using a container, a variable, something that we're going to use to store values called number, and set it equal to 5, and then set it equal to itself times 2, and this gives us 10. If we take these parentheses away and then try to evaluate lines one at a time. Do this first line, no errors, and then the second line, we get number not defined. That's because declared variables are only preserved within the scope of the code that's evaluated when it's declared. So highlighting these two lines, that's perfectly fine. We declare a variable and then set it equal to number 5, no problem. But then we can't do anything else with it. It's gone. It has evaporated into the ether, so to speak. These are called local variables. They are local to the code evaluation in which they occur, and then they're gone, which is nice for some reasons because there's no buildup of variables that we create. You know, we don't have to worry about overwriting it or anything. It's just it gets in there, it does its job, and then it goes away. So that's sort of convenient. But because SuperCollider is not your average programming language, you know, it's meant for real-time audio synthesis and audio processing, and so in that context, it's very common to have a sort of setup where you have some code for making sound, some code for manipulating sound, and then as the sound is playing, you might want to make a change, and so you might want to go down a few lines and change a number, and for that reason, you know, local variables are not so useful because you need something that persists. You know, like here's a sound and then it's playing, and then you want to be able to interpret some code later that refers to that sound, and so we have a few options for persistent variables, which I'm going to call global variables, even though they're technically environment variables. One thing we can do is simply precede a variable name with a tilde. And so now we can run this line and then run the next line. And that works. And we can even then just jump down to another line and say, by the way, what is number divided by 3? Okay, so it still works. Number is persistent. It's got a value. It's currently 10. So any variable name, if you just precede it with a tilde, then you're essentially bypassing the need to declare it. And also, as I mentioned in class, all of the lowercase single character alphabetic, the letters A through Z lowercase, can be used as global variables as well. So, for example, this works, right? N, and N persists. As soon as you add another letter, it doesn't work, right? It's only for single character lowercase letters or anything preceded with a tilde. So those are your options. So as I go through these lectures, you'll see me sometimes using local variables and sometimes using global variables, depending on context. It's something I've just sort of gotten used to over the years. And it's kind of all there is to variables. We might come back to those later in the lecture. I should get in the habit of keeping the text that I type on the screen instead of deleting it, but it's all on video, so it's being recorded. You can watch it later. I'll try to not delete the text so much. Okay, yeah, so that's shift versus command enter evaluating code. End each statement with a semicolon. It's always a good habit to get into, otherwise you're going to run into syntax errors. Yeah, I think that's all I want to talk about that. So let's move on, and I want to talk about SuperCollider as an object-oriented language. SuperCollider is an object-oriented language, and you may have heard that term before. And what that means is we're essentially thinking of everything as an object. We're thinking of computation, information, inputs, and outputs. We're conceiving of those things as messages passed between objects. So numbers are objects, collections are objects, graphical windows are objects, sound generating units are objects. Everything's an object. And every object belongs to a class. So for example, the number 2, we can say dot class. 2 is a member of the integer class. The number 7.08 is a member of the float class. The array 1, 2, 3 is a member of the array class. So there are all these different classes in SuperCollider. And for example, I might as well briefly talk about the help documentation here. If you want to learn more about the integer class, I mean, there's not too much to know about integers, but nonetheless, you can click on the word integer. You can actually even just type it here. And as long as the cursor is somewhere on this word, you can press Command D. And this brings up the help file. So this is an integer. We could just as easily type float, Command D. And whenever I say command, that's a Mac key, obviously. But if you're on Windows, it's Control D, I think. So there are all these help documentations, and it tells you a bit about what the object is, what it does. Instead of typing it and clicking it, you can also hold Shift and Command and press D, and a little search bar comes up, and so we can type array and press Enter. So again, that's Shift Command D. Right? So there's a class called function. There's a class called window. There's a class called white noise. Right? All sorts of things. It's a class for everything. And from these classes, we can create instances. Right? There's a fundamental distinction here in an object-oriented language like this one. There are classes and there are instances of those classes. And the class, let's take a look at the window class, for example. So the class window is sort of like the abstract idea of a window. You know, a window like this one, right? A graphical window. And you know, we can in a very limited way use the class window, the window class directly, but we can use it to create instances of a window. Yes, that's a great way of putting it, right? The classes are like blueprints or like a recipe for something, right? It's not the thing itself, but it provides instructions on how to make something. So most of the time, the methods that we use with classes, one of the most popular, common methods for classes is new. And in SuperCollider, we send messages to objects using the receiver.message paradigm. So in this case, window is the receiver, and new is the message. And so we can clear the post window and then shift return on this line. And we have no errors or anything. You know, nothing really happened. It's not the most interesting code. It will get more interesting, but I just want to start by pointing this out. What we're doing is we're sending a message. I sometimes will use the term message and method interchangeably. It's kind of the same thing. A method is sort of a more technical name, I guess, but it's like we're sending a message to the window class. Hey, window class, new. Make me a new window, right? And so we actually did that. The problem is we didn't store it anywhere, right? Window.new returned a value. It returned an instance of the window class, a new instance. So let's do this again, and this time w equals window.new. And again, nothing much happened. The difference here is that we now have the global variable w, which has kept a reference to our window instance. And so new is a class method, right? We've sent a message to the window class. So now we have an instance of the window class named lowercase w. And so now there's a method that instances of window understand called .front. So w.front. Any guesses what this is going to do? Suspense is killing me. Bueller? Bring the window to the front. Yeah. So in case anyone's new to Twitch, there's a stream delay. So it's usually like 7 to 10 seconds between when I do something on stream and when you actually see it. But it's just something you front some money. I wish. Yeah. So okay. So this is W. Welcome to the stream, W. It's our window. And now that we've got our instance, there are lots of other methods we can do. And I want to take this moment to go back to the help file for window, we can just scroll down and look at this. We have a list of class methods, and the very first one is new. And you can tell it's a class method because it has this little asterisk next to it. That's how in the help documentation, class methods are differentiated from instance methods. So we'll come back to this, but basically just window.new is sufficient to make a new window. And so there's a couple other class methods like close all. This is a message we can send to the window class. It says all instances that may exist, close them, close every instance, right? And then if we get down to instance methods, right? These are methods that make sense to instances of the window class. Eric, is your code all messed up? Is that what you mean? Yeah, so here's front, right? Displays the window on the screen. And here it is, right? So here's another method we can do. Let's see if I can find it here. Yeah, background. Okay, so we can let's move this over here, tuck it behind chat a little bit, and we're gonna say w.background, and we'll just running this method is going to get some value. We're saying what is the background, and right now it's nil. It doesn't actually have a value yet. Lowercase nil is a special name for things that don't have a value yet. But just like we did w equals window.new, we can say w.background equals color, which is another class. We can look up the help file for color, right? An object which represents color. Very simple. And so we can say color dot, look at all these class methods, right? We can say color dot white returns the color white, color dot gray. I think there's a rand here, isn't there? Yeah, rand. A random RGB color. So we're going to say w.background equals color.rand. And we can run this line multiple times, and it picks a new random color for our background. Now, let's see, what else can we do? Oh, w.close. Right, here's another instance method, which tells an instance of window, close. I don't think that's all messed up. I think that's normal. Well, not entirely sure. I thought mine would return a Q window as well. Anyway, Eric, does this code work? Are you able to do this, or is it giving you error messages? Let me know. Okay, so continuing on with instance methods and class methods, we can't say window.background equals color.rand. This gives us all sorts of weird, it says message background not understood, receiver class window. That's because we can't say to the blueprint or the recipe we can't say, hey, window, the class, randomize your background color. It doesn't know how to do that because it's not actually a window. It's the class window, right? And likewise, we can't say window equals window.new, and then, here, let me put this on a new line here. We can't say when w equals window.new and then w.new, right? Again, we're using a class method for an instance method, and that doesn't make sense. So not every method is defined for everything, right? As another example, let's take the string hello, right? And if we say hello dot background equals color dot rand, this doesn't work either, right? Hello is a string. It's a collection of characters in an order, and background, it doesn't have a background, right? It doesn't make sense. But we can say something like hello, hello dot reverse, and we get the string reversed. Ole. Oh, that's good to know. If you're on full screen like this, then I guess front doesn't work. Interesting. Yeah, and so here, if we go back to our window and say, there's our window, new, bring it to the front, randomize its background color, and then if we say w.reverse, what's it going to do? Flip around? I mean, it doesn't make any sense. So the point here I'm trying to make, maybe I'm belaboring the point a little bit, but objects have methods that they understand. And there are class methods and there are instance methods, and then there's an entirely different collection of class and instance methods for a different object, like a string. But that being said, some methods do work on multiple classes. Let's take a look at 2.squared. Right? 2.squared gives us 4. And the array 3, 4, 5 in square brackets dot squared. Well, what does this do, right? Any guesses what the array 3, 4, 5 dot squared is going to do? It's conceivable that we'll get the same message not understood error, because how do you square an array, right? It depends on context, right? Depends on a number of things, but it certainly could be defined. Right. So some methods are defined for. I think this will work, right? So that's how squared is defined for for arrays. You could do something with vector multiplication or index multiplication or something. There are multiple contexts in which array multiplication makes sense. But in this particular case, squared is defined for arrays, and it responds by squaring each item in the array. Now, if one of these items was, the string hello, the array containing integer 3, integer 4, string hello, and we try to square this, well, then we get an error, because how do you square a string? That doesn't make sense. Okay. So that's classes, instances, methods. So as we go through, you'll see some common methods that we'll be using. And remember that you can always look up an object, like the string class, and you can see its class methods, and you can see its instance methods, and right. Okay, so a few common classes, right? There's integers, right? 2, 3, 4, 16, 109, right? These are all integers. There are floats, any number involving a decimal point. Right? Should put these on multiple lines with semicolons like a responsible programmer, right? You get the idea. Integers, floats. By the way, you do have to when you do a float, it's got to have a digit on either side. You can't do 0.6. I think this is an error. Yeah, it's because the period is what's called an overloaded character. It's used as a decimal point for floating point numbers, but it's also used as a delineator between a receiver and a message. So that's just one of the sort of consequences of that. You've got to have, if you want 0.6, you have to actually do 0.6. We've seen a little bit of strings, right? A string is simply a collection, an ordered collection of characters. Right? There are symbols. These are kind of like strings, except they have no size. It's just another way to name something. These come up from time to time. And let's see, what else do we have? We've seen arrays. An array is delineated with square brackets, and it contains things and stuff. In a lot of programming languages, an array can only contain one type of data, but in SuperCollider, it's very flexible. An array is just, think of it as like a deck of cards, but the cards in the deck can be anything. So yeah, those are arrays. It's an ordered collection, and there are also functions, which we will encounter quite a bit. A function is delineated with curly braces, and we're going to do a little bit of a function here. So let's say the function 1 plus 4.5. Right? So if we say set this equal to x, right, what we get in the post window is a function. We do not get the floating point number 5.5, right? We have a function. A function is basically an enclosure of valid code which can be evaluated later if we want. We're sort of reserving the ability to evaluate this code later if we want to. If we then say something like value equals, no, let's not call it value. Let's call it result equals x. How do we, so if we just say this, we're going to say result is now also equal to that function. To evaluate a function, we do dot value. That gives us 5.5, right? So value is an instance method for functions, which says evaluate your contents and return the result. So functions are very handy in not just SuperCollider, lots of programming languages. It's a way to sort of make a function, just something that does something, and then you'll be able to evaluate it later if you give it a name. Sometimes I was toying with the idea of an imaginary class, you know, just to reinforce the idea of classes and instances. You know, let's imagine. I'm going to do this. I'll spare you the silliness, but I'm just going to race through this. Say we have a class called sandwich. Obviously, this does not exist. There's no sandwich class. There could be. You can make your own class. But, you know, we'd, you know, make a new instance with the class method lunch equals sandwich.new. Of course, it's not defined. We're going to pretend that this is a valid code evaluation. And, you know, once we've done that, then we can do things like lunch dot cheese equals cheddar, right? So we can set, you know, the cheese attribute. The cheese method returns the whatever cheese is on your sandwich, right? And we can set it equal to, you know, maybe this would be a string. You know, it's not really clear. It's just a made-up class. And maybe there's a method is toasted. And if we evaluate this, you know, the post window might return false. And so then we can say lunch.toast. And this, we're passing the message toast to the instance of sandwich called lunch. And then if we were to go back and check this again, this would return the Boolean value true because we have sent this message to the lunch. And then, of course, we can lunch.eat. Right. Delicious. By the way, this is a comment. I should have maybe said this earlier. Comments are really useful because the interpreter is completely blind to comments, but it's really good for when you are reading your code or somebody else is reading your code. Talk about comments just another few seconds. But so now if we've eaten the lunch, maybe maybe lunch dot is toasted returns an error or something because we've eaten the lunch, right? It doesn't make sense to ask whether it's toasted or not because we already ate it. So this is just, you know, you can think of the whole world as an object-oriented language where everything has a class and all of the physical things you interact with in your world, those are instances of their classes. And then there are methods, you know, like shirt.wash, you know, God, the list goes on and on. So anyway, that's an imaginary class there. So comments, right, anything, what is symbol, AME, and hello? I don't understand AME. Syntax error, AME, message not understood. Amen. Could you phrase your question a different way, perhaps? Aim. Did I type aim somewhere? Oh, name? Oh, okay. Yeah. These are symbols. Oh, it's. Can you not see that completely? It looks on stream it looks like it's visible. But sorry. Yeah, these names preceded with a // I think that's a // I always get those confused. those are symbols. Right, so symbol, it's basically used as a name. In a lot of contexts in SuperCollider, when you make something, you want to give it a name. It's a little bit different than storing it as a variable like this. So yeah, just a name. I think of it as, in a lot of cases, it's actually interchangeable with strings. Sometimes you have to use symbols, but anyway, that's how you delineate them, with a slash like this. Oh, okay, it's a backslash. I will try to remember that. All right, so let's keep going. Okay, so speaking of methods, a lot of methods that we've seen so far, I think all the methods we've seen so far, they stop there, right? We have color.rand, semicolon, right? Window.new, semicolon, hello.reverse, semicolon. But that's not always the case. Some methods actually need a little bit more information in order to function, and this is called providing a method with arguments. So as an example, let's go into the window class again, and we'll look at this new method. So we did w equals window.new a little while ago, and then we just stopped there. But we can actually, immediately after the new method and before the semicolon, because we're not done with this statement yet, we do an open parenthesis. And we can see a little pop-up text here, and which is just identical to the arguments that are listed in the help file for the class method, right? So we have name, bounds, a Boolean, whether it's resizable, a Boolean, whether there's a border, and some other things. So let's just take a look at this first argument, name. And by default, it is the empty string, right? When you see double quotes with nothing in between them, that's the empty string. So that's why when we do window.new.front, we see no text in the window. But, you know, a lot of times we want to have a name on the window. So we can open parentheses and then a string, provide a string, and we'll call it my window. And now, if we evaluate this, we can do w.front on the next line, maybe just for clarity, so we can evaluate this. And now you can see we've provided a value for the first argument for the class method new, which is called name, and we gave it the string my window. Right. Next is bounds, which is an instance of rect, the rect class, and this we provide the x, y coordinate and then the size in pixels. So something like this. So now you can. It's actually behind. It's behind my picture. It's back here. It's behind my webcam feed. So maybe if we pushed it over a few hundred pixels, and so now it's here. So bounds is the second argument. We're not going to get into the rect class too much here, but you can look it up, and it's a class representing a rectangle. Very simple. So as another example, something like 5.squared doesn't need any arguments, right? There are no arguments for squared. It just multiplies the receiver by itself. But something like clip, right? The clip method is defined for a number of classes, including the integer class. And clip needs to know a low boundary and a high boundary. This is used sometimes with waveforms. If you have a waveform that exceeds a certain boundary and you actually want to just clip anything below a minimum or above a maximum. And clip needs minimum and maximum. So let's say -1, comma, +1. And now somebody in chat tell me what this is going to return if you had to guess. 5.clip with the low argument for clip being -1 and positive being, the high argument being +1. 1. Let's see. Yeah, exactly. Because 5 is outside of these bounds, and so it gets clipped to the maximum, right? If we were to do -1000.clip, oh, that gets clipped to -1, right? So some methods, a lot of methods, in fact, are followed by a parenthetical enclosure with arguments separated by commas. And it's really important to know what those arguments are meant to represent, right? Order does matter. The first one is going to get interpreted as the low value, the second as the high. So, you just got to keep that in mind. So those are arguments. All right, and now I want to talk about operator precedence. Take a look at the following line, and I don't want you to evaluate this if you're following along in SuperCollider. but I want you to think about it. I want you to think about what this line is going to return. By the way, this is the asterisk. It's multiplication. Right? We obviously don't use x for multiplication because it's the letter x. So this is 3 plus 4 times 5. So give it your best shot. What is this going to return? $23, $35. Yeah, those are the two main guesses, right? Well, it returns 35, which means SuperCollider does not have operator precedence, right? It's, if you think back to, high school math or whatever, what is the acronym? I can't remember. See, I didn't pay attention in class, whatever. But, usually parentheses happen for, parentheses, exponents, multiplication, division, addition, subtraction, right? There's an order things happen. So when you write something like this, as a human, you think, okay, well, multiplication has to happen first. So we get 20 plus 3. PEMDAS, right? PEMDAS. Yeah. Yeah. So this is really crucial to know, because when you're working with signals and generators and making sound, you have to realize that there is no operator precedence, and so this can result in some unexpected values and some, in rare cases, exploded speakers and ears and stuff. So it's, yeah. Please excuse my dear Aunt Sally. That is what I remember. Yeah. So I'm going to get to the bottom line right away here. The bottom line is parentheses are your friend, okay? So if you are writing something and, there's no operator precedence and you're not exactly sure what order things are going to happen in, put things in parentheses. So in this case, now we will get 23, right? So it's please, as in please excuse my dear Aunt Sally, and then it's all, it's all parentheses. Just, if you want to be really obsessive compulsive, you can do this. I mean, you never need to do that. So there's no operator precedence. But so when you're working with numbers and multiplication, addition and stuff, just make sure that you include parentheses. Also, let's look at something else here. Let's see, 3 plus 4 dot squared. Right? 3 plus 4 dot squared. How about this? Is it just going to go simply left to right? 3 plus 4, 7 dot squared? Or is it going to square 4 first and then add 3? Right? So it's, well, methods happen first. Right? If you have a method, a something dot something, that's considered a single unit, right? And then things like addition and subtraction and whatever take place, right? So this is 3 plus 4 dot squared. Right? Not the same as what we just saw, right? Which was, oops, clean up here a little bit. Yeah, 3 plus 4 times 5. Something like this just goes left to right. So in order to do the addition first, again, parentheses are your friend. Nice. Okay. Yeah, so in this case, parentheses happen first. We get 7. 7 squared is 49. And we use parentheses. If you're not sure, even if you are sure, it does not hurt to use parentheses. It's just a good thing to do. Also, methods can be strung together, and they just go left to right. So an example that I think I did briefly a second ago, window.new.front, right? This goes left to right. We start with the class window. It gets the new method, and this becomes an instance of the class window, and then that instance receives the message front. And then I think we can even do something like dot background equals color dot rand. Is that going to work? Yay, it does work. Okay. So yeah, methods can be strung together. So, something like 5 dot squared dot cubed. This is maybe not the greatest example because mathematically we get the same result either way, but what's happening here is 5 dot cubed, right, becomes a single unit. It's the value 125, and then that gets squared, 15,625. How tall am I? I'm like 5'10", maybe 5'9". Okay, so let's see. So where were we? So that's operator precedence, and I feel like there was one more thing I wanted to mention. Oh yeah. So there a lot of these classes up here. These are actually literals, right? They're literal classes, and literals are things which appear on screen as they actually are, as we think of them. So like the integers, 2, 10, these are literals. The array, 1, 2, whatever, some array is that's a literal. Floats are literals, strings are literals, but something like rect or something which doesn't have a direct representation in text is not a literal. And like imagine if we had to in order to make the integer 2, we had to do something like integer.new 2, and that would be ridiculous, right? Every time we wanted the integer 2, we simply just type 2. So every now and then you'll hear mention of something, like it has to be a literal class, literal this, literal that. So a literal just means something which has a direct representation in text. Okay. I think we've covered a lot of good stuff so far. Oh yeah, I was going to talk about comments. So comments can be placed after a line. You just simply double / this is, obviously this is kind of a ridiculous comment because you don't need to know that this is the integer 2, but you can also put them on their own line. Let's see, let's go up, let's just take this clump of code and copy it down here. And you can put comments sort of anywhere, I think. And so this syntax should be familiar to maybe some of you if you've used stuff like C++. You can also use the following syntax to comment out a large block. You can begin with / asterisk, and then finish at the bottom with asterisk / right? And then now down here we have valid code again, right? So it's just a way to comment stuff out. And I think there's also a keyboard shortcut. I think it's command /, and that will toggle comments. And when we start doing synthesis stuff, you will probably notice that it's convenient to be able to just comment out a single line and just cut it out of the synthesis chain. It's pretty convenient that way. Okay. As we get into making sound fairly soon, we are going to be dealing with functions a little bit more. So a function again is delineated with curly braces, and it contains valid code. So we've done something like x equals, let's put this in parentheses, a function. Right, so we're going to just prepare this code block for ourselves. Var value equals value square root. I know these are like really boring functions that don't do anything, but it's important to just start with the basics here, just so we really understand what's going on. So I'm going to evaluate this, and I'm going to give this a more meaningful name, call it myfunc. Okay, so we have a global variable called myfunc, and it is equal to this function, which actually I meant to not do varg here. I'm sorry. We're not going to declare a variable. Well, we are. We'll keep it there for a second, and we'll just say value equals 6, and then we'll reevaluate this. So now myfunc has been redefined, and then we can evaluate functions by sending them the value message. Right? So here we have 2.449 blah 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 blah. That's the square root of 6. Right? Now functions are kind of useless if we can't pass values into them. Right? We want functions to sort of do something with a value, but we want to specify the input to the function as we evaluate the function. And we do that with an argument. And so this is, we can say arg value. And arguments are a lot like variables in that they have scope. So value is not going to make sense outside of this function. So we're going to get rid of this line. And so now we have a function, right, which takes a value as an input argument and sets it equal to the square root of itself. And so now, if we say myfunc.value and we just run this, I think we'll get an error because message square root not understood. It's trying to apply the square root to value, and at no point have we given value a numeric value. Right? So we can do that by providing an argument to the value message. Right? So here we can just say 2. Right? And when we evaluate this, the value 2 gets passed into the function and assigned to the input argument. And so now what we will get, I didn't need to evaluate that again, but I did anyway, it's fine. So myfunc.value argument 2 gives us the square root of 2. And so notice that when we evaluate the function, it actually returns the result of the last line. So I could even say something like, z equals myfunc.value, and then I've stored the result in the global variable z. Right? We could make another function. Val1, val2. And what we'll do is val1 plus val2 divided by 2. So this is going to take the average of these two values. Right? And so now to pass values in, we can say 3 and 6, and that gives us 4.5, right? Averages these two values together. And something interesting we can do is we can also initialize these by just setting what we're doing here is we're giving the arguments default values, right? Val1 equals 2, val2 equals 5. And so now if we just run myfunc.value without providing any arguments, it's going to use these default values. This gives us 3.5, the average of 2 and 5. Pretty straightforward. So yeah, those are functions. And I hope this is more or less making sense to everyone, and we're kind of a little bit jumping all over the place, but I think we're ready to actually boot the server now, and we'll start making a little bit of sound. So let's just put a bunch of these. Sometimes, this is basically a comment, and the comment is just a bunch of forward slashes, but I don't know, it's just a nice way to put a delineation in the code somewhere. Something I do sometimes. Okay, so as I mentioned at the very beginning, we have the SCIDE, we have the interpreter, or sclang, and we have the server, scsynth. And the interpreter is active, but the server is inactive, all these zeros over here. So to wake the server up, we need to send it the message boot. Right? And so there is a class called server, which is the abstract representation or blueprint for an instance of scsynth. Again, we think of everything as objects. And there already exists an instance of scsynth. Whenever we start up SuperCollider, an instance is created for us, and we can access that using the class method, see if I can find it, local. So server.local returns or gets the local server. So for example, if we just say server.local and evaluate this line, this gives us what we see in the post window is localhost, which is not the most meaningful thing in the world, but this represents the local instance of scsynth that is available to us on our machine. It's not running right now. I think, can we do something like is running? No, okay. There's probably a method to check whether it's active, but maybe not. But anyway, we're going to assume, it's not running. We know it's not running. And so to wake it up, we can just say .boot, server.local.boot. And so watch the bottom right corner of the IDE as we run this. And if you're following along, go ahead and boot the audio server as well, right? So capital S server.local, class method local, returns the local instance, which understands the method boot. It wakes up and we see a bunch of stuff here. We can see my hardware devices. We can see I'm using my Sapphire audio interface for input. That's how I'm getting this microphone signal in. And I'm using a multi-output device because I want to send my audio to SuperCollider and to the live stream. Sampling rate is 44.1. You know, just the basic information here. Now we got green numbers and they're moving around and the server is running. It's idle. So what I like to do is just start with a sine wave. You know, we'll just make your first sound the sort of sound equivalent of hello world. I first want to point out how you stop sound. Before we make sound, it's good to know how to stop it because and the way we do that is command period or control period if you're on Windows. And that's also available here in the menu here. Stop, right? Command period. So to make sound, to tell the server to make sound, we are going to use a function. So we'll say x equals this function. Put it in parentheses so we can evaluate a multi-line clump of code simultaneously or all at once. And we'll declare a variable. And we'll say sig equals syn_osc. There's a class called syn_osc, and it has it has more than two, but these are the two primary class methods here, AR and KR, which stands for audio rate and control rate. Yes, control is spelled with a C, but it's spelled with a K in German. So that's where it comes from. So we're going to listen to this sine wave, so it's got to be running at the audio rate. And we're just going to stop there. And so to actually play this, we do .play. So we have x, the function, which contains a declaration of a variable sig, and sig equals syn_osc, .ar. And I'm going to play this. I'm going to run this code with command enter, and then I'm going to press command period. All right? Everybody hear that? What an amazing sound. Just kidding. It's just a simple sine wave. But we're going to make it more interesting. Cool. And if you're listening on headphones, you probably noticed that it was monophonic and only in the left speaker, which is kind of annoying. And we will get to multi-channel sound very shortly. But for now, let's realize that, you know, there are lots of different types of sine waves you can make, right? They have frequencies, they have amplitudes, they have characteristics, right? And so just like we did for window.new and then open parentheses, right, which was up here, the AR method does accept arguments. And the arguments are going to depend on the class that we are using here. So syn_osc .ar, open parentheses, and we can see that the arguments are frequency, phase, mul, and add. Right? So frequency, to be fairly self-explanatory, it's the frequency of the sine wave. It's how many cycles per second. And the default is 440 hertz, cycles per second, which is why we heard a 440 hertz tone. So that's the default value. It's sort of like there's a function, and the argument frequency has a default value of, you know, 440, sort of like what we did up here. And then we have the initial phase of the sine wave. And then we have, this is a value between 0 and 2 pi. Right? And this refers to where the sine wave starts within its cycle. And 0, it starts at rest and goes up, goes to rest, goes down, and then back up. The third argument is mul, which is the output will be multiplied by this value. And so you can think of this as amplitude scaling. The default value is 1, right? That's what we had. And then add, this is a value to add to the output of sine osc. And this is essentially a DC offset, right? Whatever the sine wave is centered around, every sample of that sine wave gets a value added to it. If it's a negative value, it goes down. Now, if we're listening to this, we don't want to really add values because that's going to, offset it. It's going to give it a DC bias, and we don't want that in that case. So we'll leave that at 0. So this is the same thing we just heard. So let's change this mul argument. From 1, we're going to go 0.5. Like, let's keep going. Let's go down to 0.25, 0.125, all the way down to 0.02. And now it's very quiet. Change the frequency. Right. So I'm just I've just been using this language for so long that I just instinctively hold command and press return, and then I press command period to stop it. A slightly more elegant way to stop sound is, well, first of all, give it a name. Give function.play a name, which we've done. It's x. And then we can run x.free to stop it. Right? So run this, and then free is a message for instances of function.play, which actually returns something called a synth, and tells it, go away, destroy yourself, right? You're gone, be gone. And all right, I want to take this opportunity to look into scsynth and its features in a little bit more depth, right? So first of all, when we boot the server, or when we launch SuperCollider, as a convenience, server.local is stored for us in the global variable s. Right? So server.local returns localhost, and s returns localhost. And we can even use the conditional test double equals to check whether these are in fact equal, and they are, right? So they're the same thing. This double equals, is the equals is the single equals is like set this thing equal to that thing, right? But the double equals is like an equal sign with a question mark over it. It's s equals server.local, and it returns true or false, right? So that means instead of server.local.boot, we can just do s.boot, right? Or in this case, since it's already booted, we'll do quit. Right? So s.quit. And you can see the server goes back to sleep. And now if we try to run this sound function, we get a warning saying server localhost not running. Right, so the server needs to be booted. So let's wake it back up again, s.boot. Server wakes up, and now this is working again. So a couple things you can do with the local server. First of all, s.meter. S.meter brings up these wonderful little level meters. And so I guess it's kind of obscured by chat, just barely. But we have a pair of inputs on the left and a pair of outputs on the right. And you can see as I'm speaking into the microphone, we have signal coming in on input 0. And SuperCollider thinks of all numbered things, indices of collections, and all computer programming languages, I think, do this. 0 is the first thing, right? So this is input 0. And if we play this function, we can see that we've got a signal on our output bus, 0. Right? So signal is being written to the audio device, right? Which is this multi-output OBS device. So that's s.meter. You can close that if you ever don't want to see it. And also there's a keyboard shortcut for it, which I think is Command M. So that's the meters. Very convenient to see, you know, the strength of your signal. You obviously want to be in the green and the yellow. If you see red, then your signal is too hot and you risk clipping the signal. I'm not going to blast your ears away with that. But if you're at home and you want to test it out yourself, you can make this value something higher than 1, and you'll see it'll sort of max out here and turn red. Oh, I think you are using an older version of SuperCollider, actually, Eric. If you go to the SuperCollider menu and choose About, you might be 3.6, I'm guessing, instead of 3 point something else. That was changed at some point. The default number of input and output hardware buses was 8 and 8. And then at some point, I think people just thought that was confusing for new users, and it made more sense to just have stereo in, stereo out. You can change that. I'm not going to get to it right now because we don't really need to. We're just going to be working with mono or stereophonic sound. Later in the semester, definitely we're going to get to multiple channels. SuperCollider has absolutely no problem handling upwards of 8 or more channels as hardware channels. It's very, very simple to do. So yeah, that's the meter. S.scope. S.scope is very handy. I use this in my classes all the time. Right, so s.scope. This is a little yeah, I mean 8 channel is good. You can get 8 channel, no problem. Yeah. So okay, so let's do the scope here. I'm just gonna play the sound function again and watch the scope as I do it. Oh yeah, it's loud again. Okay, so let's make it a little quieter. Oh yeah, right. So you can see that the amplitude has in fact changed. If I increase the frequency, you see that as well. And just so I'm not harassing everybody with monophonic sound in just one ear, I'm going to get a little bit ahead of myself and just tell you that you can, at the end of your unit generator, you know, in this case, sine-osc, before the semicolon, you can put exclam 2, exclamation point 2. And this is a shortcut for the message dupe, DUP, which is short for duplication, and it creates an array of copies of whatever received the dupe message. So this is stereo, right? Stereo sound. Very fun. Just to show you, like if we have the number 5, exclam 2, that gives us the array 5, 5. If we have the string hello, exclam 4, we get an array containing 4 hellos. And when we play a function, that gets sent over to scsynth, and an array is interpreted as multi-channel sound. So it plays the 0th item in the array on output 0. It plays the first item in the array on output 1, and so on. So this is a very quick way to, yeah, so let's just, you know, the message is dot dup, and then the number of duplications. So dot dup 2, 4, 100. And so a shortcut for that is exclamation point. Right. So that's what we're doing here. We're just taking this sine wave generator and we are turning it into an array containing 2 identical sine wave generators. That's just barely scratching the surface of a topic called multi-channel expansion, which is going to be a lot of fun when we get to it. You duplicate the duplication. So you mean something like this? Yeah. It's just like messages going in series, right? So if you have 5.dup2, this returns the array 5, 5. And if you then dupe that again, you get, in this case, an array containing 3 identical copies of this thing, right? So nested arrays is what happens. And that is not something you generally do on the server because it interprets it in strange ways. It's you know, you might get a lot of signals all in one channel or some other strange stuff like that. But that's what happens. You can definitely chain those together as a way of creating nested arrays, if that answers your question. Okay, so that's server.scope. And no, yeah, it makes it stereo. Yeah, because that's how scsynth interprets arrays. So we could just as easily, you know, do something like this: sig equals the array sign osc, and then we'll just copy this, and then this. So we declare a variable. That variable sig is equal to the array containing a sign osc and then another sign osc, and then we play it. Right? But that's a lot more stuff to type, so it's convenient to just do !2. And it's worth pointing out, of course, that these don't have to be the same thing. Right, so here it puts 200 hertz in the left channel, 300 hertz in the right channel. Right? Oh, and with the scope, you can adjust the scale horizontally and vertically, however you like. It doesn't change the sound. This is just a visual thing. And I think there's some other cool tricks you can do with scope, but that's basically it. So I'm gonna free that. So yeah, there's a little perfect fifth for you. You can do some binaural beating. If I can, yeah. So right, if we had 3 ears and headphones had 3 cups, and you know 3 was a standard thing, then we could do another array. You know, if you have 8 speakers, you can do an array of 8 things, and it'll distribute them all according to your hardware outputs. So very fun stuff, very easy to do, and it's very nice that we have this xclam2 or xclam anything really. Yeah. Okay, but I'm getting a little bit ahead of myself. The last thing I want to show, another thing I want to show is so we have s.meter. There are level meters. S.scope gives us this, and let's take a look at FreqScope, the class FreqScope.new, and this gives us a spectrum view. So let's just play this again, and it gives us this sine wave. Right? Put this over here. And we'll free this, and then we can, you know, bring it up. You know, and of course we can do 2 sound functions simultaneously. We'll call this x and y. So we have 400 and maybe 800 at half of the amplitude of 400. So just double checking this here. Right, so x is a sine wave at 400 hertz, amplitude 0.2, and sig is a sine osc 800 hertz, amplitude of 0.1. And if I were to say, you know, turn this into pink noise, now pink noise, we do not want to provide something like 400 here, because it's always good to look at the class file, class help file. And we can see that the first argument for AR is mul, which is our amplitude scaling value, because pink noise is noise. It doesn't have a frequency, it doesn't have a phase, and so those arguments don't exist. All unit generators are different, all classes are different. So in this case, the first argument is interpreted as a multiplication value. So 400 is a very, very poor choice. You are going to be so sad if you play that one. So we'll just do 0.02, so very, very quiet. And we will make that stereo as well. And so now, if we play this, I should put a semicolon here, just to be extra diligent. And so now, you can see we have our pink noise spectrum right here and our sine wave. So it's a frequency, it's a spectral view of the sound, as opposed to the scope, s.scope, which is a time domain view of amplitude versus time. So these are 3 handy tools that are always good to have around. If you don't hear any sound, you know, if you're expecting to hear sound by playing a function, you don't hear anything, it's the first thing I always do is bring up the meters. And if I'm playing the sound and I don't see any, you know, for example, if I just put a 0, let's copy this here. Let's bring this down here. So if I add a, maybe I'll do silent.ar. That's a real thing. I don't know why, but I guess it's kind of nice. It is a unit generator that outputs silence. And you can specify the number of channels of silence. So we might as well specify 2. Right? And now if we play this sound function, it's playing, right? We got no error messages, and we made a synth. But I would say, if I was a moron and didn't realize that silent was silent, I would say, I'm expecting some sort of sine wave here. Let's check the meters. And if I don't see any activity on the meters, then I know that there is a problem with my code. Right? This is the first stage exiting SuperCollider. No. You can't use silent as a substitute for x.free or for the free method. Silent is a generator, right? It outputs silence, right? This is a very strange example to, I've almost never used this. I think practically never used it. But free is a method that you send to a playing function, a function which is playing and on the server. So yeah, you can't somehow use silent outside of this function to stop it. This is just a silly example here. It's a way to play a function but see nothing in the meters. Now, if I play this function and I do see signal in the level meters, that means the code is working and SuperCollider is generating sound. You can confirm it with that. But if I don't hear anything in my headphones, then I know that the problem is down the line. For like maybe on my mixer, my volume is turned down or something, or I have the wrong device selected. There's all sorts of things. So the meters are good. I'm glad to see all these questions. Yes, you can free a silent function. There's one more thing. I'll get to all these questions in just a second. But the last thing. Okay, so we have s.meter, s.scope, FreqScope.new, and s.plotTree with a capital T for tree. And this gives us a visual representation of server activity. And right now we just have this one group on the server. This is the so-called default group where all sound functions get placed. And right now there's nothing there. So I'm just going to tuck this up here so we can all see it and it's not in the way. And I'm going to go back and I'm going to play this function. And I'm going to do x.free after it. So here we go. And watch the node tree as I run this function. Right, so now we've got this white rectangle here. And if I free it, it's gone. Right? So that white rectangle represents this synthesis process. It's just a simple sine wave which is running and lives in the world of scsynth. Right? From the language, we've written some code and evaluated it, and it says sclang says, oh, server, this is for you. And it passes it along, and the server starts interpreting those unit generators and making sound. Now, if I add silent, like if I say silent.ar 2 and play this, watch the node tree again up here in the corner. And there it is. It's running. It's occupying a little bit of server CPU power. And then if we free it, it goes away. Right? We've activated a process which just generates zeros. And yes, silent overwrote the sign-osk because functions, when we, in SuperCollider, when we have a clump of code, multiple statements separated with semicolons, and we evaluate that clump, the value that is returned, printed in the post window, and if we store it as a value, the value that is returned is the value of the last line of code. So, for a function, like this, if we here's my func, it's the average of these two values. So my func.value 3,6 gives us 4.5. If we add another line here and just say 0, right? This is the equivalent in something like C where you write a function at the end, you put return the thing that you want to return. You explicitly specify it. In SuperCollider, we don't actually write the word return or explicitly say it. It's understood that your last line of code is what you want to return. So if I evaluate this now and do my func.value 3,6, we get 0. And we're going to get 0 every time because that is the last line of this function. And all of our hard work up here with declaring arguments and then doing stuff with them is all for nothing because we are dumb and put a 0 there. So the same thing is true of sound functions. when we write a function and instead of dot value, we do dot play, that goes over to the server, and the server will, the server's going to take that function, and whatever the last line is, it's going to write that to our hardware outputs. And in this case, it is silent.ar. So we declare a variable sig, and we say sig is a sine wave, but then our last line is just some garbage that doesn't do anything. So yes, in this case, we've overwritten it. Right? So if we comment this out, right, x.free, and then run it again, then it works, because now the last line technically is this one here, which is a sine wave. There are much better ways to respond to unfearing. I guess you technically could, but this is not really the way you would do it. You would do that by declaring. The best way to do that, I think, is to make an argument called we can call this mute, and we'll set it equal to 1, and then we can just say sig equals sig times mute. So now if we run this, right, the default value of arg is 1. Sorry, the default value of our argument mute is 1. And if we multiply sig by that value, well, it doesn't change, because we're just multiplying every sample value of our sine wave by the value 1. So this works just fine. And then we can say, I'll make this a little bit quieter, just so you can hear me talk. So now we can say something like x.set. Right? We've said x.free. That's a way to destroy the sound process. But set allows us to update one of its arguments. So we're going to provide the symbol mute, comma, a value. Ta-da! So what we've done here is notice how it's still running, right? There it is. It's running, but we have updated the argument mute to be a value of 0 instead of 1. So now we can set it back to maybe something like 1. And there it is, right? 0, 1, 0. And we can also set it to be, 0.1. And now it's playing, right? It's a little bit quieter. Let me put this over here. All right, we set this to 0. 0.2. So that is a very, very simple way to mute a sound process without actually destroying it. Right? All we're doing is we're multiplying all the values by 0. It's still running. It's still using just as much power. The sine osc is still chugging away. It has no idea that it's being muted on the next line. But then, so that's a way to do it sort of live, instead of freeing it and creating it again. So you can make multiple instances of the osc by continually evaluating, but free, yes. Yeah, that's a good point. So let's watch what happens if I run this multiple times, right? Right. So now we have 5. And if we try to free, I'm just gonna. Okay, yeah. I'm just gonna hit Command period, because that's the best way to do it. Yeah. So Eric pointed out something very important here. What I just did is we evaluated this clump of code. X is function.play, which produces a sine wave on scsynth on the server. And then if we run it again, the language side global variable x gets overwritten with a new instance of a synth, right? It's exactly the same, but it is in fact a new instance, and it gets plunked onto the server, and we can verify that it is in fact a new instance, and we see a second white rectangle. And then, by the way, these rectangles are from the meters here, so let's get rid of those. Yeah, so we see another one and another one, but x at any given point only refers to the most recently created instance. So yes, there are ways to avoid this, and it might seem annoying, but this is actually fairly easy to avoid. The way to do it is to give them different names, ultimately. Yeah, if we say, sound 1, wow, I can't type. Sound 1 equals this. You know, just for fun, I'm so sick of a static sine wave here. Let's just do exp_rand 200 to 1,000, right? So this is going to pick a random value between 200 and 1,000 with an exponential distribution. So it's going to slightly tend towards the lower end of the range. That's why you're seeing a lot of 200, 300, 400. So yeah, you know, you want to create these and do this. Yeah. And so, you know, you could go through and sound1.free, sound2.free. And that works. That's kind of ugly. Command period is perfectly effective in that situation. Or you can also do s.freeAll. So let's go back and just make a few of these. In fact, they can have the same name now. And s.freeAll just says to the server, just kill all your synthesis processes. But realistically, if you're writing a composition with SuperCollider, you are not going to have sound functions that play indefinitely, right? They're going to be enveloped in some way, right? They're going to have, in addition to just a generator, they're going to have a finite duration envelope, which is applied to the amplitude of a sound. And that is going to take care of starting and stopping the sound for you. That's the general rule of composing, really. Nothing is infinite, right? It's got to have a beginning. It's got to have an end. And so when we get to envelopes, you'll see that that's really the most common way of handling the problems that arise with multiple names, because you don't need to give something a name anymore. I mean, if it has a finite duration envelope, right? You would just do something like, you know, like this. You'd run this code. You're not even giving it a name, so we can't even access it, but we are operating with the knowledge that this sound function has a way of freeing itself automatically. For example, after a certain amount of time has elapsed, or after a certain event has happened. You know, for example, if you're using a MIDI keyboard to trigger notes, you press a key, MIDI comes in, and a function is played in response. And when you release the key, right, that's the trigger, so to speak, that tells the synth, okay, now you're done, go away, right? So, right, when we're just messing around with function.play and making a bunch of stuff, it's very easy to run into that problem where we've overwritten some global variable, and then we need to do command period or s.freeAll. But when we're just messing around, that's fine. So did sound 6 actually play 6 times? Yeah, I just changed the name each time. So, and you know, so sound 1, and then I played it, and we created a new synth on the server. Yeah, I was freeing each one individually. Yeah. So I could call this like A. Let's go ahead and copy this. Let me change this back to, no, we'll keep it A. And I'm going to manually make 5 of these. Or no, 5. I'll do like 3 of them. So we're going to copy this, and we're going to paste and paste. And each one has a random frequency. I'm just going to call this A, B, and C, and make these all just a little bit quieter. Right. So now if I play these, we're going to see 3 little white rectangles pop up on the node tree. There they are. And so now I can say A.free, B.free, C.free, and in any particular order, right? A is a synth running on the server. That's this, I think the one on the bottom is actually A, and then B, and then C. So just watch the node tree. I'll free B first. And so now that one has disappeared. Now we're just left with 55 and 57, which is a temporary name that gets assigned to them. And then let's free A. And then if I try to free B a second time, watch what happens. We get failure in server, node 1001 not found. That's because we already freed it, which means it's gone. It's like, it's definitely gone. It's not like it still exists somewhere. You know, B is still keeps a reference to that synthesis process called a synth, but it doesn't exist on the server. And so the server says, hey, I can't find that one, so I can't free it for you. Yeah, so sometimes you'll see node not found, failure in server. And that just means that you're trying to access a synthesis process that doesn't exist anymore. Is there a way to reset all the temporary nodes? Is there a reason we'd want to? When you say reset, do you mean remove them, like free them? If so, then yeah, I mean, there is a limit. We can't just have an infinite number of oh, you mean reset the naming system to temp_0. I have never encountered a situation where I need to do that. Most of the time, okay, so spoiler alert, this function.play business that we're doing here, this is sort of the quick and dirty way of making sound with SuperCollider. It's a very informal process. There's a lot of stuff going on behind the scenes that SuperCollider is taking care of for us. We're just saying function.play, function.play, function.play. And what's really going on behind the scenes is it's creating an object called a synthDef, and then executing that synthDef by creating a synth. And synthDefs need names, but we didn't give it a name, so it just makes up a temporary name for it. So I would not worry about that whatsoever. You can see all these nodes we've been creating here, 56, 57. I just wouldn't worry about that. I don't think there's any reason. These are just temporary names, and if we actually go through the formal process ourselves of making a synthDef, giving it a name, specifying all of its arguments and outputs and everything, and then we specifically create a synth, then we won't see these temporary names anymore. We'll see the name of the synthDef. And this is in my SuperCollider tutorial 3, which is where we transition from function.play into synthDef and synth. Okay, I want to get into, it's 9:30 or so, but I would like to just whet your appetite a little bit with different kinds of unit generators and different ways you can interconnect them, because this sine wave is, let's face it, it's very boring. It's lovely, but it's also very boring. So I'm just going to grab one of these sound functions, and let's scroll down here, and we'll just put it in parentheses for convenience so we can evaluate it. And we'll just call this x again. I'm very sloppy with my global variable names, but we're just messing around here. Normally you'd want to give these meaningful names. So okay, let's get rid of our argument for a second. And so we have this sine wave, right? And let's see, what can we do? So we originally had, something like this, stereo. Oh, by the way, if we run this now, we get variable mute not defined, right? Because mute has to be declared somehow. It's got to be a variable or an argument. So we'll just get rid of this line as well. And there's our sine wave. So there are lots of unit generators out there. Unit generators, I don't think I actually formally introduced them, but if we do a find for capital U, capital G, lowercase e, lowercase n, we get to UGen. This is the abstract superclass of all unit generators. And unit generators are objects that produce or generate or manipulate a signal, an audio signal somehow. They interface with the server, they live on the server, and they don't have any meaning in the language. Well, it's not that they don't have any meaning in the language, it's just that they are very much server objects. So in browse, if we go up to the top here and click browse, and we go to down to UGens, there is, I think, there's something called tour of UGens down here. It is Shift Command D. Shift Command D. If you're on Windows, it's probably Shift Control D. And that brings up the little search bar for. You can also go into the corner, into the help browser itself, and click on search right here. And you can also search here. So I was in browse, UGens, and tour of UGens. And so this is sort of a smorgasbord of the different oscillators that we can use. Or not just oscillators, but here are some oscillators. We have low frequency triangle wave, low frequency sawtooth wave, impulse. So I'm going to go through a few of these right now. And let's see, so we have oscillators. There's really a huge number of them. I think sort of the best way to get, you know what, I'm going to briefly look up, see if I can find this off stream here. So I prepared like a little Word document of unit generators that I thought were worth mentioning that you can sort of look up and explore on your own. And what I'm going to do is just open this and put it on stream so that when you're watching this back at some point, you can revisit it. So I have here some periodic generators. We're using sinoth. There's also saw, pulse, lf-trie, varsaw, etc. A variety of noise generators. This is absolutely not an exhaustive list. Some filters, some envelopes, some delays, reverbs, unit generators that work with sound files and buffers, a granular synthesis unit generator, some panners, and some distortion methods, which are kind of fun. So I can bring this up at the end of stream if you want to see it again, but this will also be recorded so you can come check it out at your convenience. So where was I? Yeah, let's declare another variable called frequency. And frequency is going to be equal to, let's do lf saw dot kr. We could do AR or KR here. Let's start with AR. And what we're going to use this unit generator to control the frequency of our sine oscillators. So instead of a static value of 440 hertz, it's going to be whatever value is being output by this LF saw. So LF saw, let's look up the help file. Right, its first argument is frequency, then an initial phase, which is a value between 0 and 2, and then mul and add. So it's very similar. But remember that the output of this unit generator is going to be used as frequency values. So its default range, notice that the default range of LF saw is -1 to +1. And that's no good. If we just plug that in as is, we're just going to get frequency values between -1 and 0, -1 and 1. And, you know, that's going to be, we can't really hear that. That's too low for us to hear. So let's just do, we'll start with the frequency itself of the LF saw, right? The frequency. How many times per second do we want this sawtooth wave to oscillate through its sawtooth shape? So we'll just say 1, initial phase 0, and I'm going to actually avoid these mul and add arguments, and instead I'm going to introduce an instance method that works for all unit generators called range. And range for unit generators needs a low and a high, and this is going to automatically scale the output of the unit generator onto our new range. So let's do 200 to 1,000. Right? So, semicolon, and let's just digest this for a second. We have a sound function called x, which we are playing. 2 variables. Freq is a low-frequency sawtooth wave running at the audio rate. It has a frequency of 1 hertz, an initial phase of 0, and it ranges, its output range, the values that it outputs are between 200 and 1,000. And we're using those values as the frequency to a sine wave. So let's bring up the scope. Put this over here. And let's play it. Oh, you know, let's also, oh, we have the exclamation point too as well. So it's going to be a stereo sound. Right? So like police siren sort of thing, right? If we change this to 2, the frequency of the sawtooth wave is doubled. So now it actually goes through this whoop, whoop thing twice as fast. And then we can revisit the idea of arguments. Let's call this saw freq. you'll find I'm very indecisive with my variable and argument names. It's a very bad habit. So we'll say this is 2, and then we'll put that in here. All right, so you with me so far? We've declared an argument, which means we can now do things like x.set, or yeah, it's called x, and then update this saw frequency argument on the fly. So let's just play it. And then we'll say x.set saw freq 3. Yeah, so as we get higher and higher, we start to actually produce these modulation artifacts in the sound itself. Right? Regarding Twitch's permanent archiving system, I don't know if I have that ability because I'm like a relatively new Twitch user, but I'm recording these locally and I upload them to my YouTube channel. So I'm sort of taking care of the archiving process. I'm not relying on Twitch. I'm using Twitch for the live streaming because it's a really good platform for that. But I read something, I think, that on Twitch that it's you have to be a partner or something. I'm not really sure, but all these videos will be archived on YouTube, and I'll post a link or something. My YouTube channel is not too hard to find. LFSAW does not create an exponential curve between -1 and 1. It's linear. So that's a great point. So I want to introduce the plot method. So we have function.play, right? Let's I'm just going to make a simple function here. Let's keep things a little bit separate. And let's go in and say lfsaw .ar for 0 .range 200,000. And instead of playing this, we're not going to play this because the output is between 200 and 1,000, and we don't want to listen to any signal which are outside of the positive, -1 range. But we are going to do a method that applies to functions.plot. And we're going to give it a value in seconds. So we'll say 2 seconds. And so we're going to run this, and then after 2 seconds, it generates the output of that UGen function. And as you can see, this is in fact a linear sweep from 200 to 1,000, 200 to 1,000, 200 to 1,000, 4 times per second, because we have 8 total cycles in, is that right? Yeah, over 2 seconds. So a frequency of 4 cycles per second over 2 seconds gives us 8 cycles. So, but it doesn't have to be linear, right? There's no unit generator that automatically outputs an exponential sawtooth shape. But what we can do is use expRange, which is an alternative method, which again sets the output range of a unit generator, and then maps it exponentially. So yeah, so now we have an exponential sweep from 200 to 1,000. And musically, this is going to sound more, I guess, natural, you could say. The keys at a piano keyboard, that's a logarithmic scale because as we go up by octaves, the frequency doubles each time. And so an exponential mapping like this is going to sound smoother. So we can actually, let's slow it back down. So bring this back to 1 and change this to expRange. And compare that with .range. And what you can maybe hear slightly is that with the linear range, it seems like the frequency is lingering for an extra long time in the higher range and spending less time in the lower range. If we go back to expRange, then it seems like it's spending sort of an equal amount of time with low frequencies and high frequencies. Yeah. So let's just tinker around a little bit. If we do lftry, right, lftry is a triangle waveform. So it's like a sawtooth wave, except instead of just going up and repeating, it goes up and down linearly. So we'll start with range, And let's just double check our arguments here. We have frequency and initial phase. So it's actually very much the same as LF saw. So let's just try this out. And exp range. Slightly different, but you know, an important distinction. We can do something a little bit more crazy. Yeah, maybe that's a little too obnoxious. So then okay, yeah. So let's also declare another variable called amp. And we'll set this equal to a sine wave with a frequency of 0.5. And the initial phase will be 0 for now. And then we'll make an exponential range between 0.001 and 1. And we're going to use this as the mul argument for our sine osc. So now we're doing a modulation of the frequency and a modulation of the amplitude. The amplitude is going to fluctuate between sinusoidally between 0.001 and 1 with an exponential output range once every 2 seconds. Oh, I think I might have done something wrong. Yeah. Oh no, I didn't do anything wrong. It's just we should keep this consistent. That was a little bit loud. So we're going to have the range of the amplitude modulator go no higher than 0.1. And if we wanted, we could make you know, another argument for the frequency of the amplitude modulator. You know, instead of a static 0.5, we could put another argument up here and mess with that. And a brief word about AR and KR. So we are ultimately listening to this waveform, right? It's the last line of the function, so that's what gets written to the hardware. These here are controlling the sine wave, right? We're not listening to them directly, so we don't actually need audio rate generators here. We could get away with doing KR for both of these. And this means that they're basically lower resolution waveforms, right? Things that run at the audio rate have a number of samples per second equal to the sampling rate. They're high resolution, so 44,100 samples per second. The KR unit generators have only one sample per control block. And it's a little bit of technical jargon that we will get into at a later date. But for now, it's just think of it as, you know, approximately one sample for every 64 samples of an AR unit generator. So this should still sound exactly the same. Right. But if we were to make this KR, then we wouldn't hear anything. It no longer works. We can't play a control rate signal. If we want to listen to something in the speakers or headphones, it has to be an audio rate generator. So let's comment this out for a second. And maybe this will be the last thing I do for now, because I feel like this is hopefully enough information to start tinkering with basic synthesis processes in your own sort of sound functions. I'm going to use a noise generator here. And this is going to be, I'm going to use LF noise 0.kr. Oh, actually, so yeah, David, this is a good point. I want to remind everyone that you can use pastebin to send me code. So pasting it in chat like that is okay. But if I copy it and then, you know, paste it in here, it looks like this, and then I have to do a bunch of fussing around with it to get the return characters back. So if you go to pastebin.com, you can paste your code here. Like here, I'll just, as an example, paste my code here. I'll just paste the whole darn thing. I think that worked. Yeah, so there's all my code, and then we're going to say, I guess, new paste. Maybe new paste first. How does this work? Oh yeah, create new paste. And then what we get is this link in the URL bar. And so if I then paste this in chat, then you're able to click on it, and then I can go to that link and copy your code, and it's sort of all the spacing and return characters and stuff are preserved. So, but I will try, unless you can paste it using pastebin now, I'll try to sort of pick this apart. And you're saying you can only get the sign output. Yeah, let's see. I'll click on this link here, and yeah. So we have arguments, softfreq2, freqamp, ns.ar. I forget if the space here is a problem. I guess we'll see. Softfreq range. Oh, well, the problem here is you didn't plug any of these new variables into the sine wave. You see what I'm saying? So we have all this stuff here. We have freq, we have amp, and we set them equal to these lovely complex generators with specific values. And then at the end, we just have a 440 hertz sine wave with a static amplitude and a static frequency. So what we need to do here is freq and amp. Make sense? That's a very honest mistake. So it turns out these spaces don't actually matter. Like I said, at some point, I think that SuperCollider is basically blind to white space. Yeah, no problem. So yeah, that's pastebin. So that's a great tool, I think, for this application for if you're having trouble with your code. Yeah, so as I was doing here, I was going to do lfnoise0.kr. lfnoise0 is a noise generator, and in particular, it's a non-interpolating noise generator. It is step noise. So you give it a frequency and, you know, mull and add if you want, or you can just specify a range. You know, so let's say 8 hertz, exp range 50 to 2000. So what this is going to do is it's going to 8 times a second at a frequency of 8 hertz. lfnoise0 is going to generate a random value between 50 and 2000, and it's going to hold that value for until it reaches a new value. And let's go down and let's actually plot this. And we'll just plot it for 1 second. Freq not defined. Okay, we'll just get rid of that. So this is lfnoise0, right? It's just step noise. Picks random values between 50 and 2000. And so we're going to use this random noise generator as our frequency input. It sounds like this. Right, we can make this faster. And we have arrived at the epitome of computer music. Doesn't get any better than this, right? lfnoise1 is like lfnoise0, except it interpolates linearly between subsequent values. As you can see, we've got random values, but they're, oh, it's right, but then we have exp range. So it's it is a linear interpolation. These are linear, but then exp range causes it to become exponential. Let's take that away for a second. So here we go. So a noise generator, 8 times a second with linear interpolation. So that sounds like this. Yeah. And range, as you can hear, it's just more oriented towards the higher frequencies because it's a linear distribution. And so, you know, about half the time we're in the upper octave between 1000 and 2000. So, you know, exp range is a little bit more evenly distributed between what we perceive as low and high. And just, you know, maybe one random value per second. So a sort of random meandering of frequency values. Yeah, and so we've barely scratched the surface as far as the unit generator library is concerned. But this, we have, I feel like we've more or less successfully arrived at the most fundamental way of producing sound in SuperCollider. You boot the server, you make a function, you send it the play message, optionally give it a name so that you can refer to it with set and free messages, arguments for actual values that you want to be able to input into the sound function as it's playing, variables just as containers to hold unit generators, and then you define your synthesis. Right now we're just using generators, but there's a lot of things we can continue to do. We can use filters, we can use envelopes, we can use sound files, we can actually use unit generators that read incoming signal from your audio interface, so I can actually get my voice into SuperCollider, and then I can start messing around with my voice. But it is, it's late. It's almost 10 o'clock. So I'm going to wrap it up here, but I'm going to hang around for anyone who wants to hang around in chat for another 5-10 minutes or so. You can paste bin me any code that you've been cobbling together during the stream, and if you're having trouble with it, I can help you out with it. And just answer any questions that you might have. And for those of you taking 499C, I'll see you in class tomorrow, and I'll have an in-class problem set for you to do, and one to take home as well. I'm really glad we got to synthesis, because you know, that's kind of what SuperCollider is all about. We can dink around with, you know, functions and arrays and sandwiches, you know, all day long, but the good stuff is in the sound. So yeah, I'm glad that we got to that on week 1 on the first lecture rather than putting it off till the next lecture. Also, hey, I'm Dead Tramped. How's it going? So yeah, thanks everybody for watching. If you want to log off, I'll hang around for another 5 minutes, or if you want to stick around. So yeah. Yeah, you're welcome. Trip my itch. Glad you enjoyed it. It's good to slow things down. It's good to get back to the basics sometimes. Although it is, I always find it's kind of tricky to get started from a teaching perspective with something as complex as SuperCollider. You know, I feel like you just sort of have to stumble your way through a whole bunch of stuff, you know, that, and I can totally understand if anyone is like, well, where's this all going? You know, why are we just reversing strings and squaring numbers and stuff? And but this is just sort of basic syntax and comprehension of the language and how it works, and it all comes back one way or the other. It's just good to know how everything works. How to disable the help balloon coming up after typing. Are you talking about? Oh yeah. Ugh. This thing, right? This big monstrous thing that I just press escape. I don't know how to disable it. There might be a way. But yeah, when you start typing, you know, anything, basically, this big poppy thing comes up, and, you know, sometimes it's cool because, you know, maybe you want to select something and you can push enter and it auto-completes for you. But sometimes I know what I want and I don't need the autocomplete. So if I'm typing and then I want to pause and think about something and I want to see my code, I just press escape and it goes away. Yeah, it is a little annoying, but it is what it is. Yep, no problem. You have a good night as well. Okay. So if there's no more questions, I am gonna head on out, and so I'll upload this lecture to YouTube. Somebody mentioned something about. Oh yeah, unfearing. I just mentioned this. I can export straight from Twitch. Okay. All right, but yeah. Where can one find the compositions made in SuperCollider? Well, one thing you can do is, let's see, if we go to, if you go to your applications folder and you go into the SuperCollider folder, there's a folder called examples, and then there's a folder called pieces. And maybe this is a good way to end the stream here. This is a can't get sound. All right, David, if you want to paste bin your code to me again, I can try to check it out. Yeah, one composition that I think is really fantastic is this recreation of Kraftwerk's Space Lab. So I'm just going to double click this. Yeah, and go ahead and quit the server for a second. And let me take a look at David's code first. All right, can't get sound. So you'll copy this. And before we Space Lab it up, and all right, so boot the server. Let's take a look. Okay, so first thing I notice is that this argument declaration is missing something very important. Let's see if you can notice it before I tell you. Needs a semicolon. And everything else looks good except for you are missing a period between function and play. Yeah. So semicolon on the arg, and then you just had the play message mashed up against the function. Yeah, bingo, you guys got it. So, and class not defined. The N is capital in LF noise 0. Unfortunately, really petty things like this matter a whole lot. It is LFN, all capital, noise 0. But you should be able to tell that from the error, right? If you run this code, you don't hear sound, and you see some garbage in the post window, we see error, class not defined. And then the first class we see is LF noise. And so that's a clue that you've misspelled it, right? So that's got to be a capital N. And then it seems to be working. Yeah. That was good. Just a few tiny things that will happen, but you will get better and better at catching them. So semicolon after here, a dot before the play. And then you got to spell this one correctly, but that's it. I'm going to stop the stream. Thank you all for watching. Those of you taking the class, I'll see you in class tomorrow. And yeah, cheers, everybody.